Today's AI is, well, it's brilliant, but it has a really terrible memory. It can write a poem, it can generate code, analyze super complex data, but then you ask it to learn a new skill, and it might just forget everything it knew before. This is honestly one of the biggest hurdles in AI, and a brand new paper from Google has the entire field buzzing about a potential fix. So let's break down what it is, and more importantly, why it matters. Just imagine, for a second, an AI that doesn't just learn once during some massive training run. Imagine one that continuously adapts and grows with every single piece of new information it gets for its entire life. What could we even do with that? I mean, what would that unlock? That is the huge question driving this whole line of research. All right, so first things first. To really get why this new idea is such a big deal, we have to understand the fundamental problem it's trying to solve. And that is AI's massive forgetting problem, a challenge that has honestly plagued the field for decades. It's called catastrophic forgetting, which, let's be honest, sounds just about as bad as it is. Think of it like this. You spend years becoming fluent in French, right? Then you decide, hey, I want to learn Spanish. But in the process of learning Spanish, you completely and utterly forget how to speak French. That's what happens to AI. Learning Task B can literally erase its knowledge of Task A. And that makes creating a true lifelong learning AI almost impossible with the tools we have today. So why does this even happen? Well, the reason is baked right into the architecture itself. Most of the powerful models we use today are built on something called the transformer architecture. Yeah, that's the foundation for things like ChatGPT. But this architecture has a huge flaw, a quadratic bottleneck. Now, in simple terms, that means if you double the amount of information you want the model to remember, the compute cost doesn't just double, it quadruples. It explodes. This makes having a true long-term memory just incredibly expensive. So, how do we get around this? Well, this new paper from Google Research proposes what they call a nested solution, and it's a pretty radical new idea for how AI models can be built and trained from the ground up. And let me tell you, the reaction was immediate and intense. When the paper dropped, discussions just exploded online, with comments exactly like this one, saying things like, "We were now a hell of a lot closer to AGI," or artificial general intelligence. People really saw this as a potential paradigm shift. But what exactly did it promise? This really sums up the big claims. See, nested learning isn't just a small tweak. It was pitched as a whole new way of thinking about AI. It promised a real path towards continual, lifelong learning, a way to build models that can actually modify themselves, and a way to achieve what the paper calls higher order in-context learning, which is basically a fancy way of saying learning how to learn from new information as it comes in. But you know how it goes with any big claim in tech. The initial wave of hype was very quickly met with a pretty healthy dose of skepticism. The conversation shifted from, is this the breakthrough, to, whoa, wait a minute, let's take a closer look at this. This slide just captures that debate perfectly. On the one side, you have all the hype. This is a paradigm shift. It solves one of AI's oldest problems. But on the other side, a much more sober reality check started to emerge. Critics pointed out that, it looked more like solid but incremental work. They argued that calling it self-modifying was maybe a bit of an overstatement for what's essentially a very clever caching system. And the benchmark results? They weren't quite as revolutionary as the hype suggested. And the skeptical questions got really specific really fast. Like, why did the paper mostly compare its performance against another slightly older paper from the very same team? And for a paper that claims to solve catastrophic forgetting, where was the direct evaluation of that specific problem? Critics also noticed a kind of convenient omission of compute costs and how the system might scale. It led a lot of people to wonder, is this just another big if it scales paper? A cool idea in a lab that might not hold up in the real world. Okay, so let's move past the debate for a minute. Hype and skepticism aside, how does this thing actually work? Let's get under the hood. The central idea here is to just stop treating an AI model as one giant single thing where everything gets updated all at once. Instead, nested learning treats a model like a hierarchy. It's kind of like a company, right? You've got your frontline teams dealing with daily stuff, adapting really fast, and then you have the long-term strategy department, which thinks years ahead and changes direction much, much more slowly. Nested learning applies that exact same logic to an AI. So here's how it breaks down. Some parts of the model, the fast layers, update all the time. They're like our short-term memory, processing what's happening right now. Then you have other parts, the slow layers, which update very, very rarely. They act like long-term memory, holding all that core foundational knowledge.
By updating at these different speeds, the model can absorb new info in its fast layers without accidentally overriding the crucial stable knowledge that's stored away in its slow ones.
The engine that actually makes all of this possible is called the Continuum Memory System, or CMS. It's the mechanism that manages this whole spectrum of update speeds. So instead of just a simple short-term and long-term memory, it creates a whole continuum of them, which makes for a much more nuanced and high-resolution memory system. And that's what lets it learn new things quickly without risking its core knowledge.
And this brings us right back to that self-modifying claim. It's not about the AI rewriting its own source code, nothing that sci-fi. Instead, the model actually learns to adjust its own update rules. It figures out which information is temporary and should be handled by the fast layers, and which stuff is fundamental and needs to get packed away into the slow layers. So in a way, it's a system that's actually learning how to learn more effectively over time.
So, what does this all mean? Where does this fit in the bigger picture? Let's take a look at the broader quest for lifelong learning and why this whole debate really matters. Because look, this isn't just about one paper. It's part of a massive industry-wide race to find the next generation of AI architecture. The transformer model has been absolutely revolutionary, but its limitations, like that quadratic bottleneck and catastrophic forgetting, are becoming more and more obvious. Nested learning is just one of many attempts to build whatever comes next.
And this quote just brilliantly captures the ultimate goal here. For years, we've focused on teaching AI what to know by just cramming it with massive data sets. But this new approach, it shifts the focus completely. It's about building systems that know how to learn, systems that can adapt, evolve, and manage their own knowledge continuously.
So at the end of the day, we are left with this one central question. Is nested learning truly the dawn of an AI that can learn forever? Or is it another fascinating idea that will ultimately be remembered as just another paper that was big if it scales? The answer to that is probably going to shape the next decade of artificial intelligence.